So what this seminar is on is security, and specifically sort of introducing you to the AWS framework, some of the services that we use in order to do it. But we'll always sort of start out with the generic of what are the benefits of the cloud. So elasticities. If you've used AWS at all, within the EC2 instance environment, we have auto-scaling groups. If you've used some of the managed services, you know that we can sort of contract in and out. We can scale horizontally, that type of stuff. Increasing speed and agility. This is actually my favorite thing about migrating into the cloud. Is that I can change pretty much anything, like the hardware underlying my server. I can change it in relatively straightforward, easy, etc. When I'm in a business meeting and we're discussing a potential new application and we want to look at some of the competitors, normally those applications are in the Amazon Marketplace, the AWS Marketplace, and I can, grab an EC2 instance based off that AMI, the Amazon Machine Image, and get it up and running, and then hand it off to the developers, the testers, whomever it might be, so we can look at something versus going out and finding hardware or resource access for a virtual machine and then loading an application that we're not familiar with. It takes a while. So I like that ability to leverage those templates that are already in the marketplace and then play. There's 27 regions, 20, I think, and there are more coming, over 400 points of presence. So I can, assuming governance control follows through, I can deploy as close to the client as possible. So all of my structure, because we are based on the Pacific Northwest, our resources are in the Oregon region, but that doesn't mean that's the only place we have services. So we actually have services in what I'll call other countries. So like Frankfurt, Germany, or Germany is the country, but Frankfurt is the region. We have services deployed there. And the reason why is so it's closer to the client, so less latency. When we offer classrooms, like all the desktops in the cloud, we deploy them into the region where the clients are. Like not open enrollment ones, but for like the private class type of structure. So we can just deploy those into the closest region / availability zone, VPC, et cetera. It is a pay-as-you-go. There is reservations. So again, if your business is more accustomed to that capital expenditure every 3 years, and then it's kind of free for the hardware for the next 3, we can do reservations of 1 year or 3 year to give you that equivalency of a capital expense. But really the idea is to allow you to pay only for what you consume, and then it's a monthly bill. We're not going to get into AWS organizations, which is multiple accounts, but even a single business, there's value in having multiple accounts as you grow, whether it's because of line of business, whether it's because of vendor relations, et cetera. But remember that you always have that organization that even pre-existing accounts can join. So that way you then get again, if you hit certain thresholds, you get a discount on what you're paying. Or again, if you are doing reservations, you can share that across organizations. And of course, security, which is what we're here to talk about. And so to talk about security, we really want to bring in the idea of what AWS is and like how you create one. So when you go up and you create an AWS account, you get a 12-digit code. Now you can use or assign an alias to it to make it a little bit easier to find, to interact with. And then inside that account, which spans the globe, you can build within regions virtual private clouds. Those virtual private clouds are comprised of the availability zones, which is where I can put in my networking. And then on my networking is where I could put in EC2 instance. But at the regional level is an S3 bucket. But that's like bringing me back to Oregon. My IAM users, identity and access management users, those live at the global level. As a matter of fact, I'm going to drag a web browser over onto your screen, my screen. This is my teaching environment. So if I actually go up, and you'll see I have an account ID. It's a 12-digit account ID, but I have aliased it so I don't have to remember that number. And so my alias is AWS for John. So my name's John. It's easy for me to remember. So that way, when I do go to log in, and I'm going to log in as not my root user, which has root privilege, superpowers. I don't want that. I log in with an IAM user, and this one happens to be called AWS admin. So that gives me the access. So if I go into EC2 virtual machine, notice that I'm in Oregon. So I'm in my region. And of course, if I want to build something outside of that, I can go and I choose the region that I want to go to, etc. But when I go to IAM, Identity and Access Management, notice that I go global. And so I'm no longer in Oregon exclusively. And if I actually drop down, you'll see they're all grayed out. It is because when you set up your IAM users, your principals, etc., that is literally worldwide. So it's in my account, but it's not structured down to a single region. Now I can give people permission only for a region, et cetera, and we'll talk about that. But when like EC2 instance, very specific to an availability zone, S3 very specific to a region, IAM, global. And you'll see that as you are in each of the dashboards. So the biggest thing or the easiest thing to start with is the idea of a shared responsibility model. AWS is responsible for the security of the cloud. You're responsible for the security in the cloud. So, and the line slightly changes depending on what it is that you're doing or what it is that you're playing with, etc. But always, AWS is responsible for the physical. And they are responsible for, again, the physical infrastructure. Remember that they own everything that they call the AWS cloud. So they own the data centers, they own the servers. Actually, they own all the copper or fiber in between all the data centers. They ran all of it. So they have the AWS cloud is theirs, all of the connections in between them all. So they can control that. It is not utilizing any part of the public internet. So everything is fully secured. Then, depending on, so then you'll have like a virtualization engine. So again, like a Microsoft Hyper-V or like a VMware, a Zen, et cetera. But somehow you have that virtualization level. That's kind of the dashed line, the hyphenated line, because then you are in charge of everything above that hypervisor level. So that's where you get involved with, if you do build an EC2 instance, you have to support the operating system, make sure it's fully secured and patched. You have to install the application, make sure it's fully installed, upgraded, patched for security, etc. But if you choose a managed service, so like RDS, Relational Database Services, you don't have to worry about the operating system that your database is sitting on top of because it's managed by AWS. You're still in charge of your application security. So again, you control all of that. you're in charge of your infrastructure, like the network has different layers, so defense in depth. You decide which services or what products you're going to use. And always remember that because of the things like AWS Marketplace, it doesn't have to only be AWS. If you want to do firewall security utilizing a non-AWS brand, you can. You go to the marketplace, you type in Cisco, you'll find a whole bunch of products. You type in F5, you'll find a bunch of products. You name the brand, you probably already are in the marketplace, so you just grab it. Of course, you pay for it, but the other nice thing about AWS is it's fully transparent on pricing. With a little bit of work with the business units, you can figure out pretty close to exactly how much you're going to spend every month. There's a website called calculator.aws. It allows you to go through and say, I want to run this, and this is how much data I'm going to save, and this is how much data I'm going to transfer. And it literally will break down the pricing for your region so you get a better idea. So they make you responsible for the security, but as everything else, they show you exactly how much it's going to cost. So you're like, oh, I want, the firewall. I want WAF, the web application firewall. I want advanced shield. You can go in and see the price points on each and every one of those products. So there are security design principles that AWS follows. They have well-architected framework. You may have heard of that. That is a completely different conversation. It's a different topic of one of our presentations. There's actually a tool for the well-architected framework. But one of the pillars of the well-architected framework is security. And within that pillar, we have the design principles. So there's very first one is apply principles of least privilege. We grant access only to those people that need it. We don't go beyond that, etc. So that's the idea. So we want to enable traceability. So everything we do, we want to track. And so there's a couple different services that is like CloudWatch, CloudTrail. We actually can tie it all together with EventBridge. So again, things that we can look at and figure out how to do sort of the best focus. We want to secure all layers, so defense in depth, multi-layered, different AWS services, as I was saying, like kind of on the edge, always running is Shield, but and that's free. That's just part of the account. You don't ever pay for it. So if you open an account at AWS, you do have to put a credit card on file, basically, so in case you use it. But if you don't actually put any resources there, if you just, you're pre-staging it for your organization, et cetera, you don't pay for the products that are already just built in, like Shield. Those you don't. Now, Advanced Shield, you'd pay for, or WAF, you'd pay for. API gateway, load balancers, which minimize your attack surface. All of those things will come at a cost. But the idea is that you're going to sort of choose which services you want to use. And always remember, again, that whole agility, you can change it at any time going forward. So we also want to look at how to automate your security. There's IAC, infrastructure as code. And those then leverage products like CloudFormation, which is an AWS service, and it basically is a template of your network. And you can actually, through CloudFormation, you could deploy a VPC with subnets inside of it, launch a couple servers, sort of build out the entire environment. And that's only in the development environment. And then when you're ready to say, yes, we're good to go, we want to do it in test, I can take that exact same CloudFormation template and deploy it into test. But I might, during that deployment, double the size of all the instances, because in dev there was only a couple people touching it, but as I move it into test, I got to get it ready for production. We're going to stress test it, so I can use the exact same template, just make a few changes to it, and then I know it's identical. So if you've ever been part of on-premise environments of like dev, test, production, trying to keep those three different environments all exactly the same, all in line, it's difficult at best. And it gets frustrating for your developers when what they're doing in development, they're writing, making sure it all works. And then as it moves into test or production, it doesn't work because, again, those environments were not the same. And there's more or less security in one or the other. So it gets kind of messy. So if we can automate the security, whether it's through Lambda scripting, whether it's through things like infrastructure as code, again, if you're, once you deploy something with CloudFormation, then of course we can bring in like AWS Systems Manager, we can bring in OpsWorks, and that allows us to patch our infrastructure. Sort of, again, the more we can automate, it makes it so that we don't forget, or we're not fighting a fire in one corner and forget about the other. So IAC, infrastructure as code, I'm not there yet at our company, but I'm again, you don't have to do everything at once. That's the beauty of AWS. We're actually still in a hybrid format. We still have on-premise systems, but I'm working toward being 100% in the cloud. It's just, again, it doesn't have to be do everything at once. We can slowly migrate into it. We can step back, but as we're going, we're spending the extra time to try to build it as a repeatable occurrence. So we don't have to try to remember how we did something 6 months ago. We want to protect data in transit and at rest. Now, in transit, AWS always, within the cloud, always they're using TLS. So they're always using secure data in transit. However, they're still, like from my on-premise environment into the AWS cloud, I'm using the public internet. So that's where something like VPN comes in, or Direct Connect. VPN, of course, leverages a secure tunnel, but uses public internet channels. And so you're going to also be facing congestion at these public routers. You're potentially more open to snooping and sniffing and things like that. With Direct Connect, you're paying for a dedicated circuit to your ISP. The ISP has dedicated circuits to the edge location closest to them, into the AWS cloud. And so you're not on the public internet. And so Direct Connect is one way to sort of take one more step away from public accessibility. Now, should you still run encryption? Yes. But we also have to remember about data at rest. And so there's a whole bunch of ways, whether you do it or AWS does it, that we can do data at rest per service. So what you also want to do is plan on how to mitigate, because you cannot always avoid, but the idea of a security event. So this is going back to the standard risk management protocols. You know, like what can we avoid? If we can't avoid it, what can we mitigate? And the big thing is, you know, isolate the incidents, get the services back up. And sometimes it's the service, not the data. Even when we were on premises, we had, again, disaster recovery. talk to the business, figure out exactly what it is that they need recovered and in what timeline. So RTO, RPO, the recovery time versus the recovery point. And when the business said, okay, we need email back up within, X amount of time, I was like, okay, but the amount of data we have in our email databases, like your timeline, I can't restore all the data. So the agreement was we would restore the service. So emails can come in, you could send emails out, but the actual data, like all the previous emails, that could come at a later timestamp. So not weeks away, but not within the first 3 hours. Like we could do that after we got the service up. So it's commonly referred to as dial tone recovery. You get the service back up so you can use the service, but all of your voicemail messages, all your et cetera, those come later. So that's the idea. And you can plan for that. You can look at ways around it. AWS has SLAs, service level agreements for their services. But you may want to do more because those are, depending on the service, like region specific. So such as load balancing a server. Like if you just have a server running, well, they automatically have like copies of it replicated around that availability zone so it can come back online. But there's 4 availability zones, 7 local zones within Oregon. So that server is in one of those 11 distinct areas called Oregon. And if I actually want to be able to say, well, I want to survive an availability zone outage, and again, every availability zone is multiple data centers. That's how they can have high availability for me at like no added cost. I have to set up a load balancer across availability zones. So then I add a cost, but then if they actually lose an entire availability zone, my services stay up. And so again, not the entire business, but you choose per service. So something public facing, we have highly available. Something that's for internal employee use, maybe not as much. So each service you decide. And then of course, always start with minimizing the attack surface. Now I can say this, I couldn't say this earlier. We have no public facing services that actually have public IPs. Anything that we hit is hidden behind either an API gateway or a load balancer, an elastic load balancer. And what that means is that we don't have an operating system on the internet. I remember, I've been around long enough, that our first web server for this company was literally like a web server on premises with a public IP, like out on the web. I mean, like you hit that server and there was no security other than like that server's firewall, that instance's firewall type of thing. And this was a physical server at the time. And then of course, as the internet blossomed and we needed more security, more robustness, things changed. But the philosophy of minimizing your attack surface, part of security, I mean, just is like that situational awareness. As you pull in to park your car at the airport, there's always signs everywhere that says like, hide everything in your car. Because as the people are walking by and they see something that is easily consumable, pawnable, etc., they are more likely to break your window and take it than if they walk by and it's empty. Now, you could still have all those same resources, but in the trunk or under, canopies, etc., and they just keep walking by. So that's the idea of minimizing the attack surface. is if I have an operating system out on the internet, there's exploits out there. People know about them, and there's always zero-day exploits where I'm just kind of behind on security patching, etc. I get compromised. Minimize that. Don't put the operating system out on the interface. Leave it as application load balancers are listeners. They're actually not devices. So it's not like, oh, there's a an exploit for this product, this operating system version, because all your appliances are running an operating system. Yes, ultimately there's always hardware under everything we're looking at, but from our perspective, and again, the security and redundancy of AWS, I'm doing my part, that shared responsibility model. So what is your security posture? We're going to ask those design principles and kind of get into what are you using, what services could be available to you for your use inside of AWS. So authentication, who are you? What service can we use to figure out who are you? Well, IAM, Identity and Access Management. So again, I'm going to drag this back over. Here's my IAM. Now, what we want to do is control access to the AWS for users, groups, and roles. So let's talk about those sort of 3 security principles. So again, this is my personal account, so there's not a lot of activity in here, but when I logged in and I built my account, called it AWS for John, I logged in with an email address, and that email user was the root user, and that root user has all power. And I actually played with it for a while, not knowing, better security. I didn't know what I was going to be using. Anyways, I then learned. So you don't see the root account here. The only time you see root account is when you're logged in as root. So I came in as the root user to IAM, and I built users. So, and because this is just a demo account, you can see that I called them things like admin, audits, CTO, and like ops. And then I'm a demo user because a year ago I was building it for some demo and I have not yet deleted it. Let me just delete that because it's just there and I never think about it. But these users, when you build them, they don't have any permissions or privileges, et cetera. I have to apply them. But even before that, I have to decide how they're going to log in. So you'll see that this user has a console password. So it's a password. It's how I log in. I type in the username, I type in the password, et cetera. You have the ability to add MFA, multi-factor authentication. My root account has that. This user doesn't because I'm in and out of this account constantly. But all of our corporate stuff is MFA. But this user happens to have a console password. That gives me access to what you're looking at, the web interface. Now, if I want to give users access to the command line, the CLI AWS command line, which you can download onto your local system, or I want them to use like an SDK or a CDK, the cloud developer or the solution developer or software developer, the SDK kits, I have to give them access keys. And so you can see I have an access key for this user. Not all users get access keys. So like an ops person who's primarily going into the web interface, et cetera, they're not going to be using a lot of the command line stuff. They'll only have a password. Developers who will never log into the web interface because they don't need to, they're going to be given an access key so they can actually then authenticate. So I'm going to bring up something built with an SDK. And let me open it and then drag it over. So this is simple AWS console. It was actually, I found it in the Chrome store. This password is not the password to AWS. It's just the password to get it in. And literally my password is AWS. But this is now my S3 bucket. Here is 3 different buckets I can see. Here are my EC2 instances on my VPCs. Here's my DNS. And the way I'm getting access to all of this, and it tells me what I can do, whether or not I can actually upload files, et cetera, to it, is based on this access key. So this one is right here. It's the active key. So, and then of course, part of this when I created it was the secret, which is again, only shared with the developer, et cetera. I do not have the power to change this like I do to change a password. What I do is I just generate a new access key, and you can have 2 of them at a time, which would then allow your developer to go in and you can actually have them both active at the same time. And then they'll go through and they'll use this one, make all the changes because they know the secret access to this. And then when they say, okay, we're done, you can make the first one inactive. And then, of course, I leave it there in the environment just in case, because all of a sudden there's production stuff running, all of a sudden things fail because the developer forgot one of their access keys locations to change out. So at that point, I can just make it active. Production keeps running, developers alerted, they go in, they fix the key. I can then make it inactive. And then again, in 3 months or 30 days, whatever your cycle is, you do it again. You give them a new key, they replace it all, et cetera. So just like we rotate passwords, you want them to rotate the access keys. So that's the idea. So IAM allows me to not only say how you log in, i.e. do you get a web console or do you get command line, but I can also set it up on like what privilege they get. So authorization, what can you do or not do? And we do this still in IAM, we actually can set up what they're allowed to do. So when they come in, they get authenticated through IAM. And there are other ways of doing it. We can use federation, like in corporate, we use SAML. And so when I log in to AWS at the corporate account, I actually use our corporate Active Directory as proof of who I am. And then I actually adopt a role in AWS. That's the other type of security principle besides user and group. And so we use federated login. And they also have single sign-on logins. You can actually use other branches to get in. But so I authenticate through SAML, the assertion string. And because of my security group membership in Active Directory, I have those group memberships applied to policy. So back over here. So again, if I look at the users, and I'm going to pick on the admin. This admin is actually, they've got permissions, they're applied, except if you notice it, they're actually attached from group. So there's no permissions directly attached to this user. So again, we follow the philosophy that you always set users inside of groups. So this user is actually in a group, and it's called admin all but billing. And then that group is actually what has the permissions attached. So then the user, because they're a member of that group, they get the permissions. So AWS admin, the user I'm logged in as, member of admin all but billing, they get, in this case, 2 policies. Now, if I expand this out and bring it down a little bit, this is written in JSON, and that's what the version is. That's the version of JSON. But these are the privileges that it's built in a policy, but it's the privilege. And the effect is either allow or deny. In this case, it's allow. The action is a wildcard, which means every action, list, describe, put, all of it. And then what resource is every resource, S3, EC2, databases, you name it. So in other words, administrator access, full access to AWS. But I added deny billing as well. So there's a second policy. Now, order of these policies doesn't count. What we do is it's a cumulative effect. And as soon as I see a deny statement, deny wins. Even if you allow the user, but there's a deny statement in the group and they're part of a group, deny wins. So deny always wins no matter what. We don't say, oh, follow an order and whenever you match, you stop there. Nope, everything is cumulative. I just read everything together. I focus on all the denies. So in this case, this one says deny, the action is AWS portal. So slightly confusing, but it used to be called AWS portal, but that is equivalent to billing. So if I try to get into billing, even though I was given all access, because I have a deny statement, I'm denied. So this user cannot go in and update the credit card or see the bills for the month. Now I have other users that can do that. And they're of course not assigned deny billing. So if I go and look at the policies, there's currently 980 policies. Now, the top 2, 4, 5 are me, like I built these. And one of them was built through a wizard. The other ones were built just manually, or there is, again, a visual policy editor. And you saw like the deny billing actually said it was done via the visual editor. So I can hit create policy, and that allows me to walk through what service am I impacting. It lists all my services. And then like what command, so once you choose a service. So I don't, let's go to S3 because it's like data. R, too much. S3, then of course, so that's object level storage. Then of course, what levels do you want? List, read, tagging, write, etc. And then you can choose that, and then you can even specifically assign a resource. So that's just all the visual editor to lock it down. So 975 policies are built by AWS, and every time they add a new service, we add more policies. So you can apply them as necessary. You can go through and see, so like this one, if I go in and look at that policy, you will see, again, I used a visual editor. I'm allowing them not all actions, but quite a few of them, but there was a couple things like delete I didn't want them to have. So I went through it, and then I said, what resource can you have? And I literally called out my account ID, and then things like access point, storage lens, job. These are actual commands that and can be applied to more than just the S3 bucket. I can go into other services, so I can actually, so again, access point storage lens is for like reporting. So I can actually see reports on this. So it's not just read bucket, but it's read bucket and get logging and statistics out of it. So, and of course, if you keep going, you'll see that sure enough, list storage lens configuration, public access blocks for the access points, along with listing all the buckets. And then of course, all resources. So all S3 across the organization, this user has access to. So that policy tells you what you can do, and you can always filter it down to a region. Like I could say you can build a bucket, but only in Oregon. So that type of thing. And again, denies always win. How do you monitor it? Like how much, who did what, et cetera, all those types of things. How much did you do? How much did you consume? So monitoring, if you're doing it for services, then the top level one is called CloudWatch. And CloudWatch is, again, just actively running. I happen to have my CloudWatch and CloudTrail, which we'll talk about next, logging into an S3 bucket, so I can keep infinity amount of logs. It just keeps growing, and I choose how much I want. By default, it's 3 months, but I want years worth of logging. So after 3 months, it would start expiring. By giving it a bucket to save the data in, I can keep it forever, for as long as I want to keep it and pay for it, obviously, I can keep it. But things like, the CPU processor activity on a server, that is a CloudWatch monitoring structure. Network, or if someone added a new instance to a load balancing auto scaling group, oh, new instance was added. Those are all things that can be monitored. And then if there's any event that I'm interested in, not just failure, but I'm just interested in it, I could set up an alarm, and then that alarm can call another action. It could call a script, or it could send a text message using SNS, simple notification services. So I can have it, or maybe it just gets highlighted on a dashboard. So you can customize your CloudWatch dashboard. I'd show you like a fabulous CloudWatch dashboard. Unfortunately, I don't have anything. I keep cleaning up after myself because I pay for everything that's in here. So why pay for anything? So my dashboard is pretty empty. Come here, dashboard. Yep. See, so if I add in a widget, I can choose what kind I want, and then I want logs, and it's going to pull, and it's loading up the logs. So, yeah, I don't really have anything. So there's not a lot to do. So I could start building queries, saying I want to look for EC2 instances over the last 6 weeks. But again, mine doesn't really have much of anything. So and then we're going to run the query. Oh, everything is called demo in my world. And yeah, because I don't have any log groups left. So yeah, because I just purged everything. So CloudWatch, really, I can't demo it. If I get into logs, do I have any log groups at all? Because I just purged this weekend. Yeah, I don't have anything. But that is how you can then trigger the environment. Now, we actually have CloudWatch running to EventBridge in production. EventBridge is like a single dashboard environment to allow me to sort of see everything at once and then I'll get alerted. So the other one I mentioned is CloudTrail. That one I can actually show you because just me logging in shows it. So auditing CloudTrail is anything with an API call. So when I add or remove an instance, if I launch anything, that's what is going to trigger. So, and then if I go into my dashboard, you can actually see that this again, assume role is IAM using, it's called STS, secure token, and I'm assuming a role. So it's applying, and if I scroll over far enough, it'll actually show me the resource name. That this uses an ARN, Amazon resource name. And of course, if it doesn't have a username, it's a system. If I scroll down, nope, I got nothing. See, I haven't done anything. So, but this allows me to see. The only thing that's been going on is that I logged in. So nothing really to see at this level. And then, of course, you can get, I was hoping to have something. Nope, it's just all assumed roles. I'll have to go create it. But it would then say, like, who built it? AWS admin, AWS ops, and then what they activated. So, like, if I would delete an S3 bucket or create an S3 bucket, all of that will get generated in CloudTrail. This is enabled, again, by default. Saves it for 3 months. I actually write it off to an S3 bucket so I can keep longer than 3 months, because when you're troubleshooting and you're like trying to figure out what's changed, like it worked yesterday, it doesn't work today, it's nice to be able to have this audit trail so I can go in and say, okay, filter for this resource, and I can see all the API calls to it. And I'd be like, oh, we ran CloudFormation to make this change. And then it'll normally show me, again, which user account or federated user, et cetera, which role was used to run the CloudFormation. And then I can follow up with that person and say, we might have to back it out because this is now doing X. And it's not necessarily the only thing. I mean, like that had nothing to do with it, but it's something we use to track it down. So encryption, data at rest, data in transit. So as I'd said earlier, data in transit within the AWS cloud is always encrypted. That is done by AWS always. Now, for when you leave the AWS cloud and you run on the public internet, that's then data in transit that you have to control. So, of course, obvious recommendations, HTTPS, not HTTP. Set up VPNs if you're going to be connecting your on-premises into the cloud. Use a good secure tunnel. If you're using Direct Connect, still run encryption inside of it. So extend that TLS all the way out to your system, because then, again, no IP overlap. So your on-premises cannot share the same IP address range as what's in your cloud. You can then route between them as if you're never touching the public internet. But that's all in transit. For data at rest, you actually can choose to encrypt it before you send it up to AWS. So from your on-premises environment, before you copy it up to AWS, you can encrypt it. And then, of course, you download it back to your on-premises environment and you decrypt it. So if you're, like, again, using it, sort of the gateway into storage is archival backup, all of your backups that you have to retain, you leave them as encrypted objects when you upload them. And AWS can't read them, they're encrypted. And then when you download them to do the restore, that's when the decryption occurs. But that's customer side, client side. The other is server side, which is done in the cloud. And we have a couple different possibilities there when you do it in the cloud. So there's KMS. So number one, you could just have AWS do it. Like you can just go, yes, let's encrypt. And you can encrypt databases, you can encrypt S3 folders, buckets, you can encrypt hard drives, etc. That is just AWS controlled. Or you can introduce KMS, Key Management Service. This is a paid product. And what it does is it allows you to basically upload your certificates, your keys, and then I can then deploy those keys all the way throughout your account. And that way all the data at rest is encrypted with your keys. AWS cannot unencrypt it because they don't have the keys. Only you do. And then, of course, but you can decrypt it while it's in the cloud because of KMS. So you can encrypt and decrypt at the cloud level. It doesn't, unlike the client side where it had to go back down to your data center. This can do it in the cloud, but you still control all the keys. We personally don't use this. We do encrypt our data, but we are using the AWS sort of default encryption. And so that way the data is encrypted, but I'm not managing the keys individually. So again, anything in transit, think about HTTPS. If you are going to use HTTPS, obviously you can do certificate manager. So it can control all of your publicly signed certificates through certificate manager. So do deployments. I go one extra step just because I like to, because I'm lazy. But if you've ever done web application certificate management on a highly available web application, meaning that you have 3 or 4 servers that are always up, and then you have an elastic autoscaler, so it might add 5 and 6 when it's busy, and then it collapses back down. Doing certificate management on all the production, as well as dev and test, to make sure everything's up to date and no certificates are invalid, is painful at best. Because even when you do all the ones that are running, if you don't remember to also do the auto-scaling template, then of course when it launches, it's got the old certificate, and then it's a nightmare. So if you introduce application load balancers, you can do certificate termination at that level. So all my publicly signed certs are established at the load balancer. So again, fully encrypted, but I can then have 4, 5, 6 servers behind it. They're auto scaling, they're shrinking and expanding, etc. But I've terminated the certificate at the load balancer. And yes, I can still run encrypted, but now on the inside, I'm using my own certificate management, something that can auto enroll if they're members. It's, again, remember, they're all on the private environment. They're not in the public network. They're not in a DMZ. Only that load balancer is. So again, different ways of approaching it. But I do try to, when possible, keep it simple. So instead of having to touch 8 or 9 things, if I can touch it once, then I know it's done. And so again, infrastructure as code. System manager, things where I can deploy automatically, things where I can, test the code and then run the code. That includes doing certificate updates. So for a data path, that is, of course, what can the network do? And so, of course, at the VPC level, again, we can control everything. So I'm going to drag mine over. This one I can actually show you because this one doesn't require me to do anything other than having things set up. And let me go back to Oregon. And so in each region, you can have up to 5 VPCs by default. If you need more, you contact AWS, et cetera. But so I have 2 of them. One's the default, and then there's the one I use. And if I actually look at that one, you can, if I bring it up, it actually has the ability to go ahead and have a routing table associated to it. And it has an ACL, an access control list. So that's at the VPC level. I can have routing tables and ACLs. But that VPC is actually broken down, and I'm going to sort by name so you can see them all. So make it larger. So the VPC 10 demo, I've taken that address space and I've broken it down into 12 different subnets. And each of these subnets is associated to an availability zone. Remember, a region is broken up into availability zones. So 2A, 2B, 2C, 2D. And then there's local zones, and I use LAX, so LA. But I could have been in Colorado as well, Las Vegas, et cetera. Again, like there's 7 different availability zones. I'm only using one of them, LA. So each of these we normally see as a letter, so A, B, C, D. Virginia has 6, so A, B, C, D, E, F. But that is at the network level, and every subnet, so if I actually look at just a single subnet, that subnet also has a routing table, also has a network ACL. And so access control lists are actually comprised of ACEs, access control entries, and these are read in order, and when I match, I stop. So that is why at Rule 100, I'm saying allow all traffic, and the source is wildcard, is the IP4, allow it in. So anybody coming into IP4, I'm saying let in. And also IP6, let in. Now I do have deny statements, but they're below the allow, so I never get to them. And then same with outbound. allow all out on either IP4 or IP6. So basically, I'm not using the network ACL, and not that I can't, but I don't on this one. And that is because I have routing tables, and in the routing table, I can control where you're allowed to route. Remember, I said you don't really have routers. So this network, 10.01/24, there's no router associated to it. Normally with IP addresses, if you're an IP person, with IP4, we would take the total number of IPs and subtract 2. One was for the gateway name, the network ID, and that we use that in routing tables. And then the other one is for broadcast. And so we always said, oh, /24, that's 256 minus 2, that's 254. In AWS, we actually take and we subtract 5. So the first one is network ID, that's like the 0. And then the first valid is removed for the gateway. Like that's our router, but it's just whatever the network is, the very first valid IP, that is our pretend router, because computers need to know where their gateways are. The second valid, that is reserved for DNS. So the DHCP automatically gives out first valid as gateway, second as DNS, so most servers can function because they need those two things. The third valid is reserved for future use. Not sure what if anything, but it's been reserved. And then, of course, we still have that broadcast one. AWS doesn't actually broadcast, but it's still reserved because IP4 says it's reserved. Remember that AWS runs a proprietary IP4 stack. It is not the same one you're using in-house. That's how, and of course, all of their appliances, all their routers, all the physical topology have been optimized for their IP stack. So send the exact same data through the public internet versus the AWS stack. Again, zero traffic on public internet, never going to happen, but just pretend. It's actually faster on the AWS cloud because it's been optimized. And all the hardware is all been optimized for that IP stack. So we can do security through the routing table, and I associate them per subnet. So in this one, you'll notice that I have a destination of all zeros, and it says go to IGW. IGW is a listener, internet gateway. And if anything on this public subnet has a public IP, this internet gateway listens for that public IP address. And then we pass it back to that client. If I look at private, then again, I have a 0, but now instead of an IGW, it says NAT. So if there's something on this network that has a public IP, nobody can hit it because I'm not listening for that public IP. So in this case, it will allow a server with a private IP to go to the outside to maybe get a security update, hit the internet, and come back. So network address translation. I have a NAT inside of a public subnet so they can get access to it. But there are going to be certain instances where I just, not that one, because I edited that one, obviously. I need to go fix that. What happens when I demo everything? Ooh, I demoed everything. Wow. Do I have them all that way? Okay. Let's edit the routing table association. Sorry about that. Oh, interesting. Okay, so that's what I did on that thing. Okay, so cancel. I edited the actual routing table. So let me go find private and routes and edit. Obviously, I was demoing how I can mess things up. So if I go back to my subnet and click on the private and go into a routing table, notice that there is no 000, just the 10.0/16 is available. So anything on this network can access all other cloud-based services, but cannot get to the internet, not even for security updates. So I would have to have some other option to get them access. And obviously what you saw earlier is I had said, oh, I need to update something. So I edited the routing table and put them on capable of getting to the internet. But I just removed that because that was a bad security. So I can control public versus private, but it's not like I just changed public to private by literally having that IGW in the routing table and then associating the subnet to the routing table. So subnet routing, where can they go? Network ACLs assigned at the subnet, and then at the EC2 instance or the database instance, you can associate a security group. So think of that as an instances firewall. So if I was to launch an EC2 instance, I could say allow 443 through, or allow 25 through, and then allow mail SMTP to come through. So you have to get through, first you have to be able to route to it. So you have to have a routing table that allows you to get to it, and then out. Then we have to, at the subnet level, we have to say allow whatever ports are coming through, so that filters. And then when we're in the network, we then can also have a security group surrounding the EC2 instance that says allow 443 and 25 in. But also remember, on the instance itself, we can have an actual firewall, IP table, whatever, that does or does not allow certain things through. So again, defense in depth, layer it all the way through. So that is your security stance. So it's everything from starting with IAM and building users, don't use root account, to setting up policies, which are then assigned to groups instead of users, and then users are in groups, on what they can do, and we do that through privilege, so least privileged access. I should also mention that it's way easier to add more accessibility, more privilege to a user than to take it away politically. If someone has access to something, and then you go through and you clean up security, you tighten security, and you remove that permission from them, even if they've never used it, if they hear that you took it away, that's not great for interpersonal relations. So I'm the firm believer in least privilege from the get-go. And then as they adopt new job roles or they're done shadowing, then I give them greater privilege. Because just from an interpersonal environment, it's difficult when you take something away from people. Again, security is ultimately good for the business, but security has a human factor as well. So when you say we're taking away a privilege or we're locking down security, even if you're doing it to the company, the human is going to feel like you don't trust them if you remove something. So always start with less and then add, or in what we do is everything is temporary. So we use STS, which again, security token, but they're temporary. And so kind of like, what are you doing today? That's the privilege you're going to get. Like sometimes our developers, we make them test their own stuff. I take away privilege when they're testing because I want them to see what it is like as a consumer, not a developer. Because they know how their product works and they can, so I'm like, no, you only get the access as a consumer. And then they're like, oh, we can make this better. Or, okay, wow, they have too much, that type of thing. So it's all of this, but wrapped all through it is the human factor that we have to take into consideration. Not only the public facing, like who's trying to break in, but also the internal, because if you make it too complex, then they're going to start bypassing it and, passwords pasted to their monitors, that type of stuff. So what is your security stance? is it actually viable? And part of that is how often are you refreshing your clients with your security protocols and procedures? So, what are the next steps you can do? Hopefully, you want to learn a little bit more. So there is a security fundamentals. This is actually a digital course. You can just go online, take it through training.aws. You can come in and take security essentials, security engineering. Those are classes taught by people. But no matter what, I'd say start here. I'm going to drag onto the screen. Pop it right there. So it should show up. If you click on where it says ramp up guides, it should launch in your website a link to AWS ramp up guides. And you can do, and I like this, I actually recommend this highly. So you can do it by role, so decision maker, developers, DevOps, etc. You can do it by solution. So again, what are you trying to do? So you can go through and find each individual thing that you're looking for. And again, keep going down by industry, etc. And what this allows, and I'm just going to launch it. So it's, come here, launch. Because I want to get directly into the security one without having to browse through it. This is the ramp up guide. Yay. But this is the ramp up guide for Cloud Essentials, so which I'll talk about in a second. But after you sort of get the basis down, then here is like a video, a 1-hour video that was from AWS reInvent, which is their annual, it's in Vegas, unless it was COVID, then it was digital, online. But securing your cloud, here's 50 minutes of digital training, here's a video, and just click the links and they get you into those environments. Now, if it says classroom training, obviously it's going to be with us. It's going to be with an ATP, an authorized training provider. But a lot of the stuff is just online. It's free. You just have to sign up for an AWS digital training class. Well architected, love this, highly recommend it. Because remember, those are the pillars, one of which is security, which is what this was all about. So the security pillar of the well-architected framework, you have to know what the well-architected framework is. And then, of course, it keeps going. And again, it brings in other classes. You don't need it, et cetera. You can sort of work your way down, but then you'll get down into things like the WAF workshop, the Web Application Firewall, so you can dig in and find out different environments. So I actually highly recommend the ramp up guide. We are done. So thank you.